Welcome to today's lesson. Find zeros using synthetic division. Okay, let's look at this first example. The first example here says find the zeros of this function f of x equals x to the third plus 2x squared minus 9x minus 18. Let's think what we know about this for a second. So this having an x to the third, it's called cubic. This is called a cubic function. And we know that a cubic function, we've learned in earlier lessons, it can have up to 3 different zeros. Okay? The number of zeros that a function can have is the same as its degree. And I know that the graph of this would make an N shape. So I can kind of visualize, I have this like N shape right here. It's kind of like a cursive N looking thing. So if I can visualize the graph of this, I could see how it would be possible that a graph like this would have 1, 2, 3 distinct zeros. Well, today's lesson is going to be all about how do we find those zeros. Now, let's get one thing out in the open here. If we use Desmos, Desmos has the ability, we could graph this function on Desmos, and Desmos would tell us exactly the exact location of this zero, and this zero, and this zero. And that's a fine option to be able to use Desmos to find the zeros. It's what a lot of people, mathematicians included, rely on to find the zeros. That being said, however, I want to do some examples where we find the zeros without using Desmos, doing it strictly by hand. Is it even possible? Well, I'm here to tell you that it is. It is possible to find these zeros by hand. So today's lesson, we are not going to use Desmos in today's lesson. We're going to do this by hand. It is possible, but I'm here to tell you right off the bat, it requires a little bit of guess and check, at least to find the first answer. Okay, so here's how it works. There are 3 zeros to this graph. Okay, I already know that from having done this before. But the first one, the only way we're possibly going to be able to find the first one by hand is we have to guess and check. Now, we're not going to guess and check every number in the world. We're not going to just sit here and start guessing like 1, 2, 3, 4, 5. There's a theorem that exists with functions, with polynomial functions like this, that says the zeros of a polynomial function are always a factor of the constant term. So what I'm going to do is I'm going to start making a list all the factors of 18. Now I know there's multiple ways, different ways, numbers I could add together to get 18. I could do 1 times 18. I could do 2 times 9. I could do 3 times 6. And that's actually it. That's the only way, without using decimals or fractions or irrational numbers, these are the only factors that exist of 18. Well, I'm going to put these in a list. I'm going to kind of put them in order. It could be a 1, a 2, or a 3, or a 6, or a 9, or an 18. And here's the other thing. These could also be like both negatives. You could have like double negatives to make this happen. So I'm just going to put a plus or minus sign at the beginning. The factors of 18 are either 1, 2, 3, 6, 9, 18, or a negative version of these numbers, -1, -2, -3, -6, -9, or -18. So we're going to kind of, you can either randomly do this or go in a certain order. I'm going to kind of randomly pick out a number. I'm going to pick 2. And I want to guess and see, is 2 one of the answers? And now the way that I do it is like this. I'm going to set up a little problem. It's called synthetic division, where up on the top row of this problem, I'm going to write the numbers 1, 2, -9, and -18. And if you notice, these are just the coefficients of my function. 1, 2, -9, -18. So this row right here, these are called the coefficients of my function of f of x. 1, 2, -9, and -18. I write those out in a row. And then I'm going to skip a row and draw a solid line kind of 2 rows below my coefficients. And then up in the upper left-hand corner, I'm going to draw this little half a box. This is called my guess box. And this is where I'm going to take my first guess. I'm going to randomly take my first guess. I'm going to guess 2. So I've set up this little synthetic division problem. I'm guessing 2 as my first guess in my guess box. And here's how I check to see if the 2 is the answer. I'm going to use this called synthetic division. My first coefficient here, my 1, I'm going to drop below the line like this. I draw a 1 down here. Now the rule is then, now I'm going to take the 1, I'm going to draw a diagonal to bring that 1 back above the line. But anytime I draw a diagonal, I'm going to take this value right here and multiply it by my guess. So right here, I'm going to do 1 times 2 is equal to 2. And then I'm going to add the resulting column. I'm going to add this column, 2 plus 2 is equal to 4. Okay, now I'm going to draw another diagonal. Along this diagonal, I'm going to take 4, this value 4, times my guess. So here I'm going to do 4 times 2 is 8. Add my column. This resulting column, negative 9 plus 8, that adds up to negative 1. All right, and then I'm going to draw one last diagonal. And as I do with every diagonal, I'm going to take this value, I'm going to multiply it by my guess. So I need to do negative 1 times 2. That comes out to negative 2. Add my resulting column, and this adds up to negative 20. Okay. Now, without going into too much detail, the process that we just did here is called synthetic division. And what we just did, okay, I'll show you briefly what we just did here. What we just did is let me pause here. So the way synthetic division works, we just took this polynomial 1x to the third plus 2x squared minus 9x minus 18, and we divided it by x minus 2. When you put a little 2 in this guess box, it's the same as dividing the function by x minus 2. And these answers that we get, the 1, the 4, and the negative 1, this tells us our answer. When you divide these polynomials, you're left with 1x squared plus 4x minus 1. But then here's the catch. This negative 20 that's left over at the end is called the remainder. And if your synthetic division has any remainder whatsoever, then it's a guarantee that your guess is incorrect. And so in essence, since I was left with a remainder here, I can cross off the 2. I know that 2 is not a 0 to this problem. 2 is not the correct answer that I was looking for. And this was the giveaway. In order to find a correct answer, I need to have a remainder of 0. So let's try another guess. This time I'm just going to go up the list. Let's guess a 3. So this time I'm going to go through the exact same process, but this time I'm going to use a guess of 3. So remember how we do this. I drop the 1, this 1 I drop below the line. And then I'm not going to write out the little step each time, but along this diagonal, here I'm going to take my value 1, I'm going to multiply it by my guess. 1 times 3 is 3. All right, and then I add the resulting column together. 2 plus 3 is 5. Now along this diagonal, I need to draw a diagonal right now, and along the diagonal I'm going to take this value times my guess. I'm going to do 5 times 3. It's 15. Let's add this column together now. Negative 9 plus 15 is 6. I draw a diagonal, and along this diagonal I'm going to take the value 6 and multiply it by my guess. 6 times 3 is 18. Then lastly, I'm going to add this last column together. Now here, I do get a remainder equals 0. That's a great thing. This means 3 is correct. 3 is a 0. 3 is one of my answers. Okay? And not only that, so I can right off the bat, as I make my list of zeros here, there's going to be 3 zeros. Okay? I have to find these like 3 numbers here. Well, I found the first one. The first answer is 3 because it worked in the synthetic division. And let me pause, and again, I'll kind of show you exactly what happened here. So those of you that are curious as to why the synthetic division worked, I'll show you over here. Well, everything I'm showing you over here is not necessary to get your answer, but it just gives you a little kind of the go behind. So if you multiply this function by a factor of x minus 3, in this case it came out perfectly. No remainder. And you're left with this other factor of 1x squared plus 5x plus 6. And so what we can do now, we have our first answer here is 3, but we also have the key to finding our last two answers. Because what we're going to do now we're going to take this 1 and this 5 and this 6 that we got from our division, and we're simply going to label these A, B, and C. And in order to get our last two answers, our last two zeros to the function, now we're going to do Pythagorean theorem using 1 and 5 and 6. Now give us our last two answers. I'm not going to show you every single step. Let me write a few of these in. Okay, so quick reminder of how to do the Pythagorean theorem. We plug these numbers 1, 5, and 6 in for A and B and C. And then my advice to you, the way we learned this back in the earlier lessons, I always like to find the square root first. Okay, when you take 5 squared minus 4 times 1 times 6, you get 1. And then you take the square root of 1 is also equal to 1. So we set up this little fraction. I'm going to take the square root of 1 is 1. I'm going to write that here. The opposite of 5 is negative 5. I'm going to write that here. And then on the bottom here I have 2 times 1, which is 2. I'm going to write that here. All right, and so we already had our first answer was 3. We got that from the synthetic division. But then this quadratic formula will give us our last two answers. If we do negative 5 plus 1 divided by 2, that answer comes out to negative 2. And if we do negative 5 minus 1 divided by 2, that answer comes out to negative 3. And guess what? Now I have all of my zeros. I had to guess this first one. This came by guess. These last two came from the quadratic formula. All right, and without even going on Desmos, I can promise you, without even graphing this on Desmos, that if we were to graph this original function, that this function would cross our x-axis at negative 3, negative 2, positive 3. So my guess it probably goes something like this. And you know what? We were able to find that by hand. We did not even need a graphing calculator to do it. All right, I know that was a lot of information. So let's do one problem off your homework, and I'll try to do this one as simply as I can without all the extra explanations. All right, so here's the very first question on your homework assignment. Let's do this as simply as we possibly can. Whoops, that should be a 10 right here. Okay, let's start by making our list of possibilities. What we do is we take the 10 at the end, the constant term, and we write down all the factors of 10. To get a 10, you're either going to do 1 times 10 or 2 times 5. And you know what? That's it. So the factors, it's either got to be a 1, a 2, a 5, or a 10, and they can be positives or negatives. Now what we do is we're going to write out these coefficients. 1, negative 2, negative 13, negative 10. Skip a line, skip a row, and then draw a straight line a couple spaces below that. We draw a half box up here. This is called our guess box. Okay, and I'm going to take my first guess. So I could guess a negative. I could guess a positive. You know, I'm going to just start with 2. 2 tends to work a lot, so this is my guess. Is a 2. The first number always gets dropped right below the line. So I'm always going to carry a 1 down here if that's my lead coefficient. And then every time I draw this diagonal, I multiply this value by my guess. I'm going to take 1 times 2. It's 2. Now when I add this column together, it comes out to 0. Negative 2 plus 2 adds up to 0. Along this diagonal, I'm going to take 0 times my guess, 0 times 2, and get a 0. Add up my column, negative 13. And then lastly, on this diagonal, I'm going to take negative 13 times 2 is negative 26. Add up my final column. This answer is called my remainder. Now here, since my remainder did not equal 0, 2 is not a solution. I can, in essence, cross 2 off my list. Okay, let's set this up again. Let's try a negative number this time. All right, here I've set up an exact same problem. I'm going to set it up exactly the same that I did before, but I'm going to guess a different number. Here, instead of 2, let's try a negative. Maybe a negative 2. Oh, you know what? I'm going to try negative 1. Why not? Negative 1 is my guess. This one gets dropped below the line. And then along this diagonal, I'm going to multiply this value times my guess. 1 times negative 1 is negative 1. Add the column, negative 3. Now along this diagonal, I'm going to take negative 3 times my guess. Negative 3 times negative 1 is positive 3. Add my column, negative 13 plus 3, negative 10. Now here on this last diagonal, I'm going to take this value, negative 10 times my guess. Negative 10 times negative 1 is positive 10. And this is great. This is exactly what I wanted. My remainder does equal 0. So negative 1 is a solution. Okay, one of my answers is going to be this negative 1 here. All right, now not only that, so as I start writing my list of answers, so my zeros are going to be, negative 1 is going to be one of them. Now remember, there's 2 others I have to find, but I don't have to guess and check the last 2. The last 2, I can take these numbers, the 1, the 3, the negative 10. I can call these A, B, and C. And I'm going to do the quad formula. The quadratic formula will give me my last 2 answers. I'm going to do that real quick. So when I plugged all these values into the quadratic formula, the square root, it ended up being the square root of 9 plus 40. So it ends up being the square root of 49, which is 7. I'm going to write a 7 here. The opposite of 3 is negative 3. 2 times 1 is 2. So here's my last 2 answers. I'm going to have a negative 3 plus 7 divided by 2. Whoops. Ignore that. Negative 3 plus 7 is positive 4 divided by 2. Oh, and hold up. I made a mistake here. And I see it already. Go back here for 1 second. I made a big mistake. This is a negative 3 right here. All right, this should have been a negative 3 for the b value. That should have been a negative. That should have been a negative. Now, the good news is the square root still turns out the same. But this should have been a positive 3. Okay, the opposite of negative 3. This should have been a positive 3. So let's try this again. So my first answer is going to be 3 plus 7 divided by 2. And that comes out to 5. And then my last answer is 3 minus 7 divided by 2. That comes out to negative 2. So listen, here's my answers. The negative 1, I found that by guessing and checking. The 5 and the negative 2, I found those from the quadratic formula here and here. Now, just to let you know, you could have guessed, you might have guessed the 5 first, or you might have guessed the negative 2 first, and these would have worked just as well as guesses. And then you would have used the quadratic formula to come up with the other 2 answers. But as it happened with us, we guessed the negative 1 first, and then the quadratic formula gave us our last 2 answers. Okay? So if we were to graph this on Desmos, you don't have to do this because we were able to do it by hand, but if you were able to graph this on Desmos, guarantee the zeros would come out at -2, -1, and 5. -2, -1, and 5. It probably would have looked something like this. But we were able to find those zeros by hand. All right, and that's how we do it. That's how you find zeros by hand. Best of luck on this assignment. Take care.